Hello, can you hear me?
Yes, sir.
Yeah, okay, thanks. So, yeah, in this session, we will solve this for week 7. Okay. So, let me share my screen and then after that, we'll discuss. Solve this. Are you able to see my screen? Is my screen visible? Hello.
Yes, sir.
Yes, sir. Visible.
Yeah, okay. So, there is bunch of questions which we'll try to solve. Okay. So, let's solve for this first question. This is kind of like straightforward. We'll be using Taylor series for this. The f of x equals 3 and f dash of x and f double dash of x is given. And we need to find the value of this f of 7. Okay. So can you compute this? Can you do this? Okay. So try to solve it. I'll give you like 3 minutes of 4 minutes to solve it. And after that, we'll look at the solution. All right. I know it's easy, but still, you can just try and then start solving it. Okay? Please raise your hand when you're done with the problem. Okay. Please raise your hand once you have completed it. Yeah. So shall we discuss solution, or do you still want some more time?
Yes, sir, please discuss.
Yeah. Okay. So we have this the expansion of Taylor series is let's say we have this of express eta d, then that is equals to f of x plus f dash of x into into x plus eta d whole square by 2 into f double dash of x, right? So what to do is we just need to substitute this value there. The eta d will be equals to 7 minus x over 1. Okay, and once we substitute that, we'll be getting the answer. Okay, do you want me to solve it on paper, or can you move it?
Oh, can you please solve it, sir?
Yeah, okay. Give me a second. Let me get my whiteboard. So according to Taylor series, we have f of x plus, let's just denote the theta d as some capital D, okay, equals to f of x plus f dash of x into d plus f double dash of x into d square by 2 plus and so on, right? So this higher order terms we can ignore. Just we can so this f of x is given as, that is f of 6 is given as some value, and f dash of 6 is given, f double dash of 6 is given, right? So can you tell me those values? Okay, yes. f of 6 is 3 and f dash of 6 is half. F double dash of 6 is 2. Right? So what does this say? So f of 6 is 3 and f dash of 6 is half. And f double dash of 6 is 2. So that's what's mentioned in the problem. Alright. So now what do we have? Need to calculate f of 6 plus 1. Okay. F of 6 plus 1. This gives, this will be equal to f of 6 plus d will be equals to 1. Okay. Into f dash of 6 into 1 plus f double dash of 6 into 1 square by 2. Okay, we will ignore this higher order terms. That is this f triple dash of x into d cube by 3 and all. Okay, this will give f of 6 as 3. 3 plus half plus f double dash of 6 is 2. So 2 into by 2. So this will be equals to 4.5. Okay. Did everyone get this answer? So you solved 4.5. You're not able to get the same answer. What did you get? What answer? Are you able to get this answer 4.5 for those of you who are raised hands?
Yes, sir.
Yes, sir.
Okay. Yeah, the PDF was not shared. Okay, we just solving it in the using the PDF. Okay, the PDF we are not able to find that PDF file.
So can we solve this using linear approximation, the first problem? If I do x minus 6, that could also be a way of solving it, right, sir?
Linear approximation, like just having it as like ignoring the f double dash.
No, since the eta is not given, I mean, can I do it like fx plus f dash of x into x minus 6 and plus f double dash of 6 into x minus 6 the whole square by 2. So that could also be a way of solving this question, right, sir?
Actually, both are same, right?
Both will give the same answer?
Actually, both are same. Na? So what I essentially done is same. Na? So
Okay,
what you have done
okay.
is, I assume that theta d as is capital D, right?
Yeah.
Theta d as is capital D. So what you told is that you will be having this 7 minus 6 whole square by 2,
Correct.
right? That
Correct,
is nothing
correct.
but D. So which I have
Okay.
taken it here.
Okay,
So
so
it's the same thing.
it will finally give the same. Okay, somebody is
Yeah.
saying linear approximation is same as Taylor series.
Yeah. So basically, what we have done is like the formula which you are using, the formula from the Taylor series is exactly the same.
Okay, sir. Thank you, sir.
So we'll move ahead. Now we'll be using this gradient descent problem. Okay, we have this f of x comma y equals to x y square and eta equals to 1, x naught comma y naught, the initial approximation which mentioned. What will be the function after what will be the value of function after 2 iterations as per gradient descent? Okay, so can you solve this? I'll give you like 5 minutes to solve this problem. After that, we'll look at solution. If you completed the problem, please raise your hand.
So for multivariable function, we will have to use gradient, not f dash x.
Yes. You need to use this gradient
Okay.
for the multi-dimensions. Yes.
Oh,
So the entire session we are not doing it on PDF. Okay. So it is just a normal PDF file. I will just show you question and we'll be answering it. Please do not share your answers in the chat box. Are you done with this problem?
Yes, sir.
Okay. Shall we discuss the solution or what is it?
Yes, sir, let us discuss.
Okay. So right now what we have is we have this x comma array f of x comma is given, right? So we need to use the gradient descent to find the del f of x. Okay. Then only we'll be able to find this x1 comma y1. Okay. So let's try to do that. So f of x comma y is equals to xy square, right? The xy square and x0 comma y0 is 2 comma 2. Okay. So now del f of x is going to be xy square. We should be doing partial derivative with respect to x, so that gives y square. And partial derivative with respect to y, it gives 2xy. Okay. If you substitute the values of x0 comma y0 here, we'll get 2y square as 4 and 2xy it will be equals to 8. Okay. So this is the value of del f of x. So x1 y1 is equals to x0 like x0 y0 plus minus eta into del f of x, right? So what was mentioned about the eta there? The eta is mentioned to be 1.
Eta was 1.
Yeah, eta is 1. So which means that we'll get we'll get this as 2 and then minus 4 8, right? So this will be minus 2 minus 6. Okay, this is after the first iteration. Okay, now let's go for this x1 y1, sorry, x2 y2. To find x2 y2 we need to find the del f of x again. So yeah, the value will be the same, which is y square and 2xy. Now we need to substitute it for x1 comma y1, not x1, not x0 y0. Okay, so since x1 is the value of x1, the x1 is minus 2 and x2 is minus x. Minus 2 comma minus x. If you substitute here, we'll get y square as 36, 2xy as 12, yeah, 24. Okay, we'll get del f of x as 36 comma 24, 36 and 24. Now when we get this x2 y2 again, it is equals to x1 y1 minus eta. Now this will be eta 2. Okay, eta 2 into del f of x at x1 comma y1, right? Now eta 2 will be equals to 1 by 2, right? So since we have this 1 by t plus 1 policy, x1 y1 is minus 2 minus x minus eta 2 is half now into 36 24. This gives it as 36 by 2 is 18, minus 2 minus 18 is minus 40, and this gives minus 12 minus 18. Right? Am I correct? Did you get the value of x2 y2? Did you get the same values? Hello? Did you get the same values x2 y2?
Sir, actually, I have not understood how we are getting eta 2.
How are you getting this eta t?
Yes, sir, eta 2.
Okay, so initially Initially, we'll have some particular for
So I
gradient
think it is
descent,
mentioned to be 1.
eta is mentioned to be 1, but the thing is,
Yeah.
we have this gradient descent, right?
Okay, okay. Yeah.
So it's going to decrease. It's going to be 1 by t plus 1, and so on, right? Clear?
Sir, but if they're supposing there are 3 iterations, so every time you just go on adding 1, is it? So it was 1 divided by p plus 1, then it will be 1, I don't know, p.
So
Supposing it is 3
it
times.
has like 1 by 2, 1 by 3, 1 by 4, and so on, right?
Okay, that is if your eta is 1. But if eta is not 1, then?
So let's say like initially eta is half, right? Then for second one, then we'll have 1 by 3, 1 by 4, and so on. Okay.
Sir, if eta is 1, 1 by 2, 1 by 3, then shouldn't it be given as 1 upon t in the question? It is given 1. So shouldn't we take it constant in every iteration?
No, for gradient descent algorithm, we won't be having this constant eta, right? For gradient descent, we won't have a constant now. So for gradient descent algorithm, the eta equals to 1 by t plus 1, right? Eta t is equals to 1 by t plus 1. If you remove from the lectures.
So in the question, I guess it was given eta is equal to 1. It wasn't given eta is equal to 1 upon t plus 1. I think it is saying that keep it constant in every iteration. Because there were questions in AQs and practice questions in which eta was given to be 1 upon t plus 1, so on as well.
Okay. Okay then. So yeah, for now we just we'll solve taking this eta as constant. That will give this as minus 38 and then minus 30, right? Yeah. So this will be the value of x2 y2. Now what we need to do is we need to find this value of f of x comma y, right? So this is nothing but xy square. You need to substitute this value, so this is nothing but minus 38 into 30 square. Okay. If you substitute this, you'll get this answer. All right. This is okay.
Yes, sir.
Yeah. Okay. Let's move on to the next one.
Sir, so in this question, the third iteration would be 1 by 3, right? The value of eta would be 1 by 3. And then for fourth iteration, it would be 1 by 4.
Like, yeah, so according to what was mentioned by student, and yeah, I think what she said was correct. The eta since it was mentioned as constant, right? So we won't be following the normal gradient descent 1 by t plus 1. Okay. We just take it as constant for each iteration. Okay. We won't take eta as 1 by 3 or such.
So sir, only if eta is given as 1 by t plus 1, only then would we go ahead and do that 1 by 2, 1 by 3 and all.
Yeah.
Otherwise, we take it as it is given, right? For all the iterations.
Yeah.
Okay, sir. Thank you.
Okay, so here we have the similar problem, but with a different f of x comma y and different eta. Okay. So they give x0, y0, and they're asking for value of x2. They're not even asking for value of f of x comma y. They just asking for value of x2. Okay. So can you try this?
Yes, sir. I think it's similar to the first one. So yes.
Can you repeat? You can get. So do you want to try this or do you want to try this problem?
Yes, sir. We'll do it.
Yeah. Okay.
Sir, so the moment you say it is x2 means we have to do 2 iterations, correct? No?
Can you repeat?
Sir, I said since the question is asking for x2, that means
Yeah.
we have to go for 2 iterations.
Yeah. So initially we'll get, for the first iteration we'll get x1, and for second iteration we'll get x2.
Okay, sir.
So if you completed, please raise your hand and we'll discuss the solution. Shall we look at solution?
Yes, sir.
Others, yeah, shall we look at it? Okay.
Yes, sir.
Yes.
So we have f of x comma y as 2xy plus 2x minus x square minus 2x square. Okay. So this plus 2x minus x square minus 2x square. Okay. So and we have what is the value of x naught from y naught?
So -1, -1.
Minus 1. And what is the value of beta?
0.2.
0.2. Okay. So del f of x it's equal to, first we should be doing this partial derivative with respect to x. So 2xy plus 2x minus 2x square, this we need to do this partial derivative. So this will give 2y plus 2 minus 2x. Okay. Next we need to do this partial derivative with respect to y. So this will give 2x minus 4y. Okay. So this is this partial derivative and we need to substitute at -1. So this will be -2 plus 2 it gets cancelled out and this is as 4. Sorry. Use it as 2 and then we have 2x minus 4y which will give it as again 2. Right? This is the answer, right? Del f of x at -1. Okay. And now this will give x1 y1 as x0 y0 not this one minus 0.2 into 2. This will give it as x0 y0 is -1. So this will give it as minus. So this will give it as -1.4 and -1.4, right? So this is value of x1 comma y1. Now what we need to do is we need to find del f of x at this x1 comma y1. So this will give, substituting this for x1 comma y, so x1 comma y1, that is -1.4 minus 1.4 will get it as -2.8 plus 2 and then plus 2.8. Right? So this will be again give 2. So this will be 2x minus 4 which will be equals to minus 2x or minus 2y. That will be nothing but 2.8. Okay. So this will give 2.8. So this means that the value of del f of x at x2 y2 is 2.8. So now this will mean that x2 is equals to x1 plus theta into this del f of x part. We need to just take out this the top part, which is the 2. So this means that minus 1.4. This is minus, sorry, this is minus, so minus 0.2 into this value is 2, which you got there. So this will give it as minus 1.8. Did you get this answer?
Yes, sir.
Everyone? Others?
Yes, sir.
Yes, sir. Yes, sir. Thank you.
Okay. So we'll move ahead. So this problem is clear, right? Do you have any questions here?
So only I want to understand this eta, no? How it has to be changed from, supposing there is a question, in what type of question eta will change from one iteration to another?
So it changes when eta is a function of t. That is, eta is a function of the iteration or that. Yeah, if eta is a function of iteration, right? Like we have this 1/2 power t or 1/t plus 1 or something like that, right? 1/2t plus 1, something like that. Then the value of eta changes with the iteration. Okay.
Okay. So t there is the number of iteration, is it? Which I was not following.
Yeah.
So okay. Understood.
Okay. So now we'll move on to the next question. This should be fairly easy, yes. What value of x? F of x equals to 2x minus 8 whole square is we know. This is straightforward, right? What's the answer? Hello. What is this answer?
So x is equal to 4.
Yeah. Right. So this is clear now. Obviously, the minimum value possible for this will be 0 because it is square of a square. So which can either be positive or 0. So it can be 0 when 2x minus 8 is 0, which gives x as 4. Okay. So I'm not solving for this. We'll move ahead to the next problem. Okay, so now let's look at this. Assuming x0 as 2 and eta as 0.05, what is the number of iterations required to reach x in the previous question using the method of gradient descent? So that is, we had this f of x as 2x minus 8 whole square, right? And we know that that x star is 4, right? Now the question is, I'm assuming x0 initial solution as x0 as 2, and then after how many iteration I'll be arriving at solution. That is, I'll be arriving at 4. After how many iterations I will arrive at 4 using the gradient descent method. You can consider an error of 0.1. That is if you get 3.9 or like if you get 3.9 higher. Okay, like if your answer is within the range of 3.9 to 4.1, then you can stop and then you can conclude that we had a solution. Okay, clear? What I'm talking about?
Yes, sir.
Okay. Sorry, this error is not for this x value, but for this overall f of x value. Okay. If the f of x is plus or minus 0.1, right? Then that particular x can be considered a solution. Okay. Clear?
So which means that we substitute fx 4 in fx and then find out what is the actual value and then consider an error of 0.1, is it?
Yeah, like
we calculate the value of fx at 4.
No. We like the value of fx at 4 is 0. Okay.
Yeah.
What we do is after each iteration, you can calculate for fx. You can calculate for fx, and if that fx is within the range of plus or minus 0.1, then we can consider that that
Okay.
particular x value is a solution
Okay, sir.
according to gradient descent.
Okay. Thank you, sir.
What? Can you repeat? Okay, so try solving this. So we need to use this previous equation. Okay, that f of x equals to 2x minus 8 whole square. We are finding solution for that using the gradient descent and assuming x naught as 2 and theta as 0.04. So third iteration after we completed it. Is it like too long or what?
It is taking some time, sir.
Okay, okay.
They got a punch card with 20 punches on it. And that's all the investment decisions they got to make in their entire life. They would get very rich because they would think very hard about each one. And you don't need 20 right decisions to get very rich. You know, 4 or 5 will probably do it over time. I I've told students,
Favorite sports person?
Favorite sports person? Cricket or anything?
anything.
Favorite sports person? I think for me is I would name two.
Sir, there is some background noise.
Yes, sir.
Yeah, it's from outside. Yeah. Let me know when you're done with this. Okay, when you're done with the problem. And if you're done, please raise your hand so that I will complete. So then shall we look at the solution? Shall we look at this solution?
Yes, sir. Yes, sir.
Yeah, okay. So what needs to be done is the way to proceed is straightforward, right? Like we have x naught as 2 and f of x is 2x minus 8 whole square, and f dash of x will give 2 into 2x minus 8, right? And into again, so 4 into 2x minus 8, correct? This is f dash of x, and we have x naught as 2. Now what we need to do? We need to find x1. X1 is nothing but any doubts? X naught minus eta into f dash of x. What is the value of beta? Beta is mentioned as
0.05.
point
0.05.
0.05. Okay. So beta is 0.05. So by substituting this x naught as 2, what will we get? We will get this 4 into 2 to the 4, 4 into minus 4, which is as 16, right? Minus 16, right? So this x1 value will be equals to 2 minus of 0.05 into minus 16. Okay. What will this be? 16 into 0.05.
0.8.
0.8, right? So this will be equal to 2.8. X naught
Yes,
is
sir.
2.8. And I'm pretty sure f of x1, it will be greater than 0.1 as this, right? So let's go for x2. We will go for x2. And for x2, f dash of x is again 4 into 2x minus 8, which will give x1 is what? 2.8, right? So by substituting it, 2 into 2.8 minus 8, do we get? We get
0.48.
We get, no, I'm talking about this value of f dash of x here. We get f dash of x is minus 9.6, right? Correct? (2.8) into 2
Yes, sir.
minus 8 into 4. Yeah, 9.6 minus 9.6. So this will give x2 as x1 minus eta into f dash of x, which will be equals to 2.8 minus of 0.05 into minus 9.6. So this will give this will give the answer as 3.28, right? So I don't, right? So I don't think even for f of x2 will get this value within the range of lesser, like within the range of 0.1. So we'll move to the higher one. So x3 will be equals to x2 minus eta into f dash of x2. Now for f dash of x2, it is equal to 4 into 3.28 minus 8 again. So that will be 3.28. Sorry, 3.28 into. So that will be equals to minus 5.76. Substituting it here, we'll get 3.28 minus 0.05 into minus 5.76. So this will give us what? We'll get minus, sorry, we'll get 3.568, correct? X3.
Yes, sir.
And what is the value of f of x3? Shall we try and substitute? 2 into 3.568 minus 8 whole square, right? So it will be nothing but, can someone compute and tell this value? F of x3. No. So look at it. What is the value for that? 3.568 into 2 minus 8, which will give it as 0.864, and 0.864 square value is 0.746, and it is not in the range of lesser minus 0.1. So we still need to move ahead. Okay. So we need to compute for this f of x4. So first we need to compute x4. X4 is again equals to x3 minus eta into f of x3, and f of x3, which is nothing but f dash of 3.568, that will be equals to minus 3.456. Substituting that, we'll get 3.568 minus 0.05 into minus 3.456. That will give this value as 3.7408, right? X4 value is 3.7408. So now f of x4 is 2 into 3.7408 minus 8 whole square. Okay. So let's try to do this. So which is nothing but 0.5184 square, which will again be greater than 0.1. So this will be in the order of 0.25. So that is still again greater. So we need to compute x5. X5 is again 3.7408 minus beta f dash of 3.7408. So now f dash of 3.7408 is equals to what? Can someone compute that? 3.7408. So that is equals to 2.0736. Obviously, there will be minus 2.7406, and that into 0.05 will get this whole value as 3.8448 or something. Okay, approximately we'll get this value. Now for this particular x5 value, we'll compute f of x5. F of x5 it will be equals to 0.3104 square. I think that's still gonna be greater than 0.1. Yeah, no, it is within the range. Okay. So what we got is all right. So at this x5 value, we got this value as 3.8448, right? So this is approximately when you compute this, when you substitute this x5 here, we're getting approximately 0.09 something. Okay. So the answer for this particular problem is 3.8448. Like if you get it somewhere close to that, then it's totally alright. Okay.
Sir, I have a doubt here.
Yeah.
Since the error is given as 0.1, right?
Yes, yes.
And we know that the minimum value occurs at 4. X is equal to 4, right? So, yeah, so if we look at the error of 0.1, then shouldn't it be 3.9? So 3.9 to 4.1 is the range, right? So plus or minus 0.1 of 4 should be 3.9 or 4.1. So here we got a value of x5 as 3.844. But if we calculate x6, then we get it as 3.90 something. So isn't that more like, isn't that within the range of the 0.1 error that was given in the question? Because we are calculating the value of x, right?
Yeah.
Or rather the value of the function. And we
I also had that same question. Do we consider the error for the fx or the x basically?
We will be considering the error for x, f of x, not for x. Okay. See, because our total goal is to minimize this f of x, right? Okay. So we'll be considering the error for f of x, not for x.
Okay.
See, the value of x, it's not important to us. The value of f of x, it is important to us, right?
But so when we were doing those previously, when we were doing the error calculations and loss functions and all, we were considering the error E as b minus p, wherein we considered each point and actually found out the error for each of those points. So going by that, it would be for x, right, sir?
Previously we found for each point the error you were saying, right?
Yeah, yes, sir.
Yeah, here also we are doing the same thing. No? So we are finding the error for each point. But the thing is, that overall error is we'll be finding with respect to f of x, right? Our desired objective function, right? So
Okay.
that's what the error no, which we are looking at.
Okay, so the distance that we measure is basically f of x is what you're saying.
Yeah.
Okay.
So that's our main objective. That's like we want to minimize that value, right? So
Okay.
we should be looking for the error such that the f of x, the minimum value, no, it's like close to this 0.1 range.
Okay, sir. Got it. Thank you, sir.
So same problem, the problem that was mentioned in this Q1. Now using another method. Okay, so this was for this previous problem, this one. Okay, f of x as 2x minus 8 whole square, right? We can find the xn plus 1 using this formula too. Okay, this is Newton's method for optimization. Okay, what they we used xn minus eta into f dash of xn, right? So instead of that we use xn plus 1, xn minus f dash of x by f double dash of x. Okay, we use this formula. So by using this formula, how many iterations do we take? Like, do we need to get the solution? So that's a question. Okay. So for the same problem of 2x minus 8 whole square, 2x minus 8 whole square, and assuming x naught as 2, how many iterations do we need to get the to arrive at solution? Okay, that's a question. Okay. Clear?
Okay, sir. So here, instead of eta, we will just do f dash x1 and divided by f double dash x. Correct?
Yeah.
Okay.
So this what you can do is we can just do it for 1 or 2 iterations. Okay. If it is taking too long, then we can just give it out. Okay, because we have other problems to solve for. Okay. The important method is should be doing this process correct. Okay. And if you are able to do that, then that's good enough.
I think it's coming to iteration, sir.
Can I repeat?
In second iteration it will come.
Okay, second iteration itself we are getting, correct? Okay, great. So basically, what this says is that this is even better, even better algorithm. Okay, even though the like there is more complexity involved, but we'll be getting a optimized solution with less number of iterations. Okay, clear this problem? Do you want me to solve this?
Yes.
The first iteration at least.
Yeah, okay. So I'll just show this for the first iteration. So what we have got is, what I will do is I just listed all the values which we got. We got x1 as 2.8, x2 as 3.28, x3 as 3.568 for the previous values. For using this GD, we got x1 as 2.8, the x2 is equals to 3.28 and x3 as 3.568, right? x3 as 3.568 and so on. We had x4 and then at x5 we added solution 3.8448. Okay, and this x4 equals to 3.7408. 3.7408. Okay, now using this Newton's method, we'll compute and then we'll compare the values of x1, x2, x3 which you are getting. Okay, so what is Newton's method? xn plus 1 equals to xn minus f dash of xn divided by f double dash of xn, right? And f of x is 2x minus 8 whole square. So this gives f dash of x as 4 into 2x minus 8. Okay, and f double dash of x, that will be equals to 8x.
2 into
right?
2x.
What?
Sir, f dash is 2 into 2x minus 8.
No, sir, it's 4.
No, it's 4 only.
f2 dash x is 8 only, right?
What? F double dash of x? Yeah. Okay, yeah, it is only 8. F double dash of x is only 8. So xn plus 1 equals to xn minus f dash of x by f double dash of xn, right? So what we'll get? So basically, we are getting this f double dash of x irrespective of x, it is equals to 8, right? So what is the value of 1 by 8 or 1 by f double dash of x?
0.025, 0.0125.
0.125.
Makes a 0.125. 0 extra.
0.125. And what is the eta value which we took before? 0.05, right? Eta value for the
Yes.
eta value for the GD which we took it as 0.05. Okay, and since we are using this higher eta value, you are able to get to the solution very quickly. Okay, so basically at least for this particular problem, since f double dash of x is constant, it is independent of x, we'll get this xn as xn plus 1 as xn minus 0.125 into f dash of x. Okay, since we are having this higher eta value, we move quickly, okay, when compared to the previous one. We are having this higher steps here, that's why we move quickly. Okay.
So in this x0 we will always take as 0 because nothing is given. So every time we have to take, if nothing is given, x0 has to be taken as 0, is it?
X0? This one? No.
X0.
You can just take the previous one itself. 2L. Okay. X0 is 2, right? Like we can just use the previous information. X0 is 2 and then we can
Understood. Yeah.
Since it is like same problem, do it in a different way, right? Otherwise, like if it is not related to the previous problem, then the x0 will be mentioned. The x0 will be mentioned. Okay.
Yes. Clear.
So in that Newton's method, which is solved, so here the first iteration will be x0 minus f dash of x0, right? Where x0 is 2. So we put the value of 2 where xn is mentioned for the first iteration.
For the first iteration, x1 equals to x0 minus f dash of x into 0.125, right?
Correct.
Yeah, correct. Then
so So I think I'm getting the value of 4 in the first iteration only. So that is the one that we want, right?
We're getting 4 in the first iteration only.
Yeah, because 2 minus 4 into minus 4 upon 8. So 2. Can you just go back to your calculation sheet and quickly?
Yeah.
That would be helpful.
So what do we have? What is value of f dash of x for first iteration? It is equals to 4 into 2x minus 8 to 4 is equals to minus 16, right?
Yes.
Okay, minus 16. Yeah, you're getting it as 4 in the first iteration. And the thing is, you're getting the exact value. Okay.
Yes.
This worked out because it is this quadratic equation. Okay. And if it is not the quadratic equation, you might not be getting this exact solution. Okay. Using reduced method. If it is, let's say of the order of 3 or 4, you will not get the exact solution. Okay.
Okay.
Clear?
Yeah.
Okay. Solve for this next problem. You need to find the positive value of x where f of x is known. Okay.
Yes, sir. So it's 1, I think. I got 1.
Yes, yeah. Done?
Yes, sir.
Okay. So what is the value? Where the f of x is known?
So 1, 1.
1. So just 1 minus 1 minus 1 plus 4. Okay. So you did this f dash of x and then you solve for that quadratic equation, right?
Yes, sir.
Okay. And by solving the quadratic equation, you'll be getting 2 values. Okay. Your condition should be that the f dash of x, sorry, the x value should be greater than 0, and f of x should be minimum. Okay, which means that f double dash of x at that particular point it should be greater than 0. Okay. Clear? I don't think you need to check for the f double dash of x also.
I'm getting the value of x as 1.
Yeah. The correct answer is 1. Okay. So we can solve for that if you want. We have this x cube minus x squared minus x plus 1. Okay. So we have now f of x as x cube minus x squared minus x plus 5, right? So f dash of x is equals to 3x squared minus 2x minus 1. Right, so this is nothing but 3x minus 1 into 3x plus 1 into x minus 1. Am I correct? Yeah, right. So this will give x as minus 1, sorry, x as 1 or x as minus 1 by 3. Okay, since we need the positive value of x, so the value of x will be 1. So at value of 1 we'll be getting the minimum value. We can check that whether we get minimum value or maximum value by checking for this f double dash of x. Okay, f double dash of x equals to 6x minus 2, and the f double dash of x at x equals to 1 is equals to 4. Okay. It's nothing but f double dash of 1 is 4. So since f double dash of x is greater than 0, f double dash of x is greater than 0 and f of x is equal to 0. Okay. Let's say like this point is x1 or something. Okay. If f double dash of x1 is greater than 0 and f of x1 is equal to 0, then at the point x1 there will be a minimum. Okay. Clear?
Yes, sir.
Okay, go ahead. Yeah. So assuming the initial guess as 0.75 and steps as 0.25, what is the number of iterations required to reach x in the previous question? So it is just this particular question. By doing the same thing, x naught as 0.75 and eta as 0.25. What is the number of iterations required to reach x? Okay. Consider an error of 0.001. That 0.001 it is again for f of x. Okay. So basically, you should be checking for this f of 1 value, and whatever answer you get this through this GD, right? The f of x minus f of 1, it should be within the range of 0.001. Okay. Clear?
Yes, sir.
Okay. Yeah. Try this problem.
Sir, can you show the FX expression again?
What? Yeah,
FX
okay,
expression.
yeah.
Yeah.
Sorry, yeah. Please raise your hand when you are done with this problem.
Sir, I think मेरा तो कुछ calculation error हो गया. I'm getting something very painful. It's not simply converging at all.
Okay. Yeah, check for it. Like go back and check. Try to find where am I missing. First thing, you should find the f of x value at 1, okay? So that is equals to 4.
Yes, sir.
Minus 1, 4, okay? And then
Yes, sir.
whatever value you get with respect to this f of x star, so that should be within the range of 4. That means the acceptable range is 3.999 to 4.001.
So after first iteration, I'm getting value of f of x as 4.013. So is that acceptable?
4.013.
Yeah.
Okay.
The value of f of x.
Okay. So can you, what about second iteration? What value did you get at the end of second iteration?
Yeah, I'm doing it.
Yeah, okay, try doing it. Okay. You moved in the correct direction, but the problem is you moved like too much. That could be because of the eta value. We do not worry about that.
But sir, इसमें we have to try to reach 1, no? We have to try to reach 4.
We
Why
are
is it
trying to
trying
reach
to reach 4?
one value.
1 तो मेरा
Yeah, by
conversion
reaching
है, sorry.
x value as 1, we'll reach f of x as 0.4. Okay, we should reach the x value should be close to 1.
X value has come very close to 1.999, but then
Okay.
fx is going far. It is not 1. Fx is going, I don't know where.
fx, it should be close to 4, right? But it's 0.999.
That I got in third iteration or fourth. I mean, I've lost this thing.
Yeah. Then you're done right.
Okay. Yeah.
Shall we look at solution? Okay, only two people have completed it. What about others? Do you want time or?
Yes, sir, we can discuss the solution.
Okay. Others, shall we discuss? Okay.
Yes, sir. So the answer is after 3 iterations.
Okay. Look at that. Okay, so we have f of x as x cubed minus x square minus x plus 5 and x naught equals to 0.75 and eta is equals to 0.25, right? Am I correct? 0.25 or 0.2? It's 0.25. Okay. So we have eta equals to 0.25. F dash of x is equals to 3x square minus 2x minus 1. Okay. Which gives f dash of 0.75 is equals to what? Can someone tell me? What is the value of f dash of 0.75? 3 into 0.75 square minus 2 into 0.75 minus 1, right? So that is equals to 3 into 0.75 into 0.75. That is equals to minus 0.812, right? Correct? So this will give x1 as 0.75 minus 0.25 into 0.8125, which will be equals to 0.953.
Yes, sir.
0.953.
Yes, sir. I also got the same thing. Yeah.
So this is value of x1. Okay. I don't think f of x1 it will be close to this 4. So we'll compute x2. Okay. So what is the value of x1? 0.953. So f dash of x1 is equals to 3x square minus 2x minus 1. Substituting this, we'll get 3 into 0.953 square minus 2 into 0.953 minus 1. Okay, what is this value? Can someone tell me this?
Yeah, I got minus 0.811.
Minus 0.811?
Yeah, this is what I got actually.
Okay.
I don't know whether it's right or wrong.
Yeah. Okay. So we get as yeah, it is minus 1 point. It is 0.18, right? Minus 0.181. Minus 0.1813. Did you get this answer? Dash of x1. Okay, so this will give x2 as 0.953 minus 0.25 into minus 0.1813. Okay. So 0.1813 into 0.25 plus 0.953. So that gives the value as 0.9983, right? x2. So we check for f of x2 here. We check for f of x2 here. So this is nothing but 0.9983 cube minus 0.9983 square minus 0.9983 plus 5. Okay. We check this.
But sir, in this actually we need not check fx, no, because actually the goal of the question is to reach x close to 1. So we need not check actually fx.
No, our goal is to reach to f of x, not the x.
No, sir, but the question was that error in x should be 0.001. So only we have to go on calculating till we reach x net value, no? So fx, usme how does it play any role actually?
Okay, right. Consider error 0.001. So that is not for x. Okay, that is for f of x. As I told previously, right? So our value should be that whatever x value we are getting, that f of x star it should be close to the actual f of x value, right?
Acha. Okay.
So this will give okay, so this itself it's giving me
4.003 something.
Yeah, something like 0.0005 something I'm getting. Okay, actually I'm getting even more zeros. So yeah, whatever xt value I got for xt value is 0.9983. For that itself, I'm getting my f of x value is close to 4, right? So they mentioned the error of 0.001. My error is even less. So yeah, the answer is 0.9983. Okay, I got it in second iteration. Okay.
Yes.
So in this calculation, if you take all the values as only 2 decimal places, then you don't arrive at x2 with that error value. So,
can you repeat again?
So suppose if I take all the values with 2 decimal places here, then fx2 I get it as 4.01, which is not close to this error function. So I guess if you've been given an error function of a higher decimal place, probably we should take higher decimal places in all the calculations. Is that true, sir?
Yeah. So see for this particular scenario, it's always better to take higher decimals. Okay, up to like 4 you can take.
Okay, sir.
Yeah, and that too you cannot just take it as 0.99 because after that you have 8, right?
Yeah.
It's not even like 1, 2 or something to ignore. Okay, so it's always better not to ignore that this part. Okay, you might ignore 3. Okay, because that's comparatively less,
smaller
but
value.
you ignore this. Okay.
Yeah. Thank you, sir.
Okay, so the final problem for us, that is the same problem we'll be solving using this Newton's method. Okay, this xn plus 1 equals xn minus f dash of xn by f double dash of xn, right? So for the same problem of this x cube minus x square minus x plus 5, okay, you assume x naught as 0.75, okay, and then you see how many iterations we need to arrive at the value of x. Okay, Consider same error 0.00. Let me know when you're done with the problem, okay? And this time, since the equation is of order 3, you will not get it straight away. You will not get straight away the answer as well. You need to go through the iterations, even through Newton's method. Okay.
Sir, I got, I think, after second iteration.
Okay, you got it after second iteration. Okay. What about others? Shall we look at the solution, or is it like okay? You can do it by yourself, right? This one, last one. Hello, shall we look at solution?
So let others say. I've already done, so maybe others can say.
Okay, so I'll wait for 3 more minutes. Shall we look at solution?
Yes, sir.
Okay. So f dash of f of x is x cube minus x square minus x plus 1, right? And f dash of x is 3x square minus 2x minus 1. And f double dash of x, it is 6x minus 2, right? So x1, it will be equals to 0.75 minus f dash of x divided by f double dash of x. So this one, dash of x, what did we get? So we got it as minus 0.812 farad. So this is minus 0.8125, whatever f double dash of x. So this will be equals to 6 into 0.75 minus 2. Okay. So this is basically 3 minus 2. Okay.
4.5 minus.
Yeah, 4.5 minus 2. Correct. So this will be given as 2.5, right? Okay. So shall be 2.5, which will be equals to 0.75, 0.8125 divided by 2.5 plus 0.75. So 1.075. Okay, so in total it's going to be 1.075. So this is the value of x1. And now when we compute the value of f of x1, what is value? I think it's going to be greater than 4.001. Right? So we'll compute the value of x2. x2 is equals to 1.075 minus f dash of 1.075 divided by f double dash of 1.075. Okay. So what is f dash of 1.075? So this is going to be 1.075 cube into 3 minus 2 into so this is going to be 0.5768. Okay. So for this is going to be 0.5768. Okay, what about the double dash of x? So that's going to be 6 into 1.075 minus 2. So that's nothing but 4.45. So that is, this one is 4.45. In total, this gives 1.075 minus 0.5768 divided by 4.45, which is equals to
So the f dash 1.075, I think is 0.316869.
0.3169.
Yes, sir. I also got 0.3169.
Okay, let me check. Okay, yeah, sorry, yeah. So 1.075 square into 3 minus minus 2 into 1.075. Okay, yeah, 0.3168, correct. So this value is 0.3168. So 0.3168 divided by 0.3168 divided by 4.45, which gives 0.00711, is equals to 1.075 minus 0.71119. So that gives the value is 1.003, okay, approximately. And if you substitute this value, what are we getting?
Sir, I got 4 point so many zeros and 2. I think 5 zeros I got.
This value, x2 value or f of x2 value?
No, f of x2 value.
Okay, then that's good, right? That means that our answer is like this value is like even close to the approximate, like the actual value. Okay, so this x2 value, which is 1.0038, the second iteration it gives us the correct answer. Okay, at the second iteration we arrived at the solution. Okay, clear? Okay, so yeah, so that's it for today. Okay, I hope this is clear.
Yes, sir. Thank you, sir.
Okay, thanks everyone.
Thank you, sir.
Have a good day.
Thank you, sir.